Hi everybody! This video is just going to be a talk through of your study guide. So I'm going to go through each problem and complete it. So if you have your study guide in front of you and you happen to have any questions on any of the problems, hopefully watching me complete them will answer some of your questions. So to start, I wrote out here the topics to study. You should know how to find the greatest common factor. You should know how to factor out the greatest common factor. And then you should also know how to factor binomials. That's kind of putting those two things together, including the idea of the difference of two squares, which in class we called dots. So in the first section, it says to find the GCF of the following. You can absolutely make your factor trees for these if you need to, but just for time's sake, I'm just going to use my knowledge that the GCF of 24 and 48 is 24, because the greatest number that there is that goes into both 24 and 48 is 24. So that's the answer. Moving on to number 2. We have some variables included now, so we have to include those in our GCF. Looking at 15 and 45, the GCF between those two numbers is 15. Again, you can make your factor trees if you need to. And this one has an x, this one has an x squared. They share an x. So therefore the GCF is 15x. Moving on to number 3, we've got a few more variables. Looking at each thing separately, looking at the number and each variable, we're going to see what they have in common. So we have 8, 12, and 28. The biggest number that goes into all three of those is 4. Now we look at the variables. This one has x cubed, x squared, and x. So they all only share an x. Alright, now looking at the y's. This one has y squared, and these two don't have y's, so they don't share any y's. And now the z's. Only the middle term here has a z, so they don't share that either. Therefore, the GCF is 4x. The next section involves factoring out the GCF. That includes leftovers. So here's what we do. Taking number 4, we're going to look at the GCF of both terms. GCF between 3x and 6 is 3. So what we're doing is we're pulling out the GCF from both terms. And our operation is division. So the 3 is going to go on the outside. When we take 3 out of 3x by dividing, we're just left with x. And when we take 3 out of 6 by dividing, we're left with 2. So this would be our answer. So that's what it means whenever the directions say factor out the GCF. Moving on to number 5, we look at the number 8 and 36, and then we look at the x squared and x cubed, see what they have in common. So the biggest number that goes into both 8 and 36 is 4. This has x squared, this has x cubed, they share x squared. So our GCF that we're pulling out is 4x squared. Our leftovers go in parentheses. When we take 4x squared out of 8x squared, we are just left with 2. When we take 4x squared out of 36x cubed, we are left with 9x, because 36 divided by 4 is 9. And when we take x squared out of x cubed, we're left with just x. And there we go. Same deal for number 6. We're finding our GCF first, so we have 7 and 21, the GCF is 7. X squared and x, they share an x. Y and y squared, they share a y. Now we're pulling the 7xy out of both terms. So taking 7 out of 7, we're left with just 1, or we don't have to write that. Taking x out of x squared, we're just left with x. And taking y out of y, no y's left. Taking 7 out of 21 by dividing, we're left with 3. Taking x out of x, no x's left. And taking y out of y squared, we are left with just a y. And that is our answer. Moving on to number 7, we've got a few more variables. So we're looking at both terms and finding the GCF. GCF between 32 and 56 is going to be 8. X cubed and x squared, they share x squared. Y squared and y, they only share a y. And they don't share a z since the second term does not have one. Pulling this out of both terms, 32 divided by 8 is 4. Taking x squared out of x cubed leaves us with x. Taking y out of y squared leaves us with y. And taking nothing out of z, we have our z left. Next term, taking 8 out of 56 leaves us with 7. X squared out of x squared, there's no x's left. Y out of y, no y's left. So we are finished. The last section of our study guide is on factoring binomials. So it says factor the binomials completely. If there's a GCF, it must be factored out first. I can't stress that enough. Your step 1 is always to look for a GCF. Then you can go on and do your regular stuff. But factoring out the GCF is key every single time. Okay? So starting out with number 8. X squared minus 49. There is not a GCF between these two terms. So we can go on and recognize this as the difference of two squares. Subtraction sign means it's the difference. And two squares, x squared is a perfect square, and 49 is a perfect square. So what happens when we have that situation? You should be able to recognize that. When that happens, we're making our two sets of parentheses and taking the square root of each term. Square root of x squared is x. Square root of 49 is 7. So this is how we set it up. One of them is plus and one of them is minus. And the reason it's a plus and a minus is because if you distribute it out and actually do the math here, the two middle terms are going to cancel out and you're going to be left with our original problem, x squared minus 49. You can do that check on your own time. Okay, moving on to number 9. X squared minus 25, there's no GCF. But we recognize this as another difference of two squares situation. We have the difference because it's a minus sign, and we have a perfect square and a perfect square. So we set up our two sets of parentheses. Square root of x squared is x. Square root of 25 is 5. One is plus, one is minus. And you're done with that problem. Number 10, we have 2x squared minus 50. Again, if there is a GCF, it must be factored out first. 2x squared minus 50, there is a GCF, and it's 2, so we need to factor that out first. So we need to pull out that 2, leaving us with x squared minus 25. And normally we would kind of stop here and assume that we're done. But since we know about this whole difference of two squares thing, we can look here and say, oh wait, we're not done. Because this x squared minus 25 is actually the difference of two squares. We have a subtraction sign and we have two perfect squares. So we need to factor that more. We're going to keep our GCF chilling in the front here. And we're going to break this down into our two sets of parentheses. We have x and 5. One is plus, one is minus. Done. The question that you should always ask yourself along with this is there anything more I can do? In this case, no. But if you would have stopped at this step, then you would have not have been finished. Okay, moving on to number 11. We have 4x squared minus 9. There is no GCF that we can pull out, but we recognize this as the difference of two squares. 4x squared is a perfect square, and 9 is a perfect square. So we set up our two sets of parentheses. The square root of 4x squared is 2x, and the square root of 9 is 3. We have our plus and we have our minus. Okay, moving on to number 12. If there's a GCF, it must be factored out first. We have x to the fourth minus 25x squared. What they have in common is x squared. So x squared is our GCF. Let's factor that out first. So when we take x squared out of x to the fourth, we're left with x squared. When we take x squared out of 25x squared, we're left with 25. Normally we'd stop here and think that we're done, but that is not the case. And I'm sure you know why. We have difference of two squares. Okay, this right here can be factored more. So we're going to keep our GCF out front. We're breaking this down into our two sets of parentheses. Here we go. I don't know why I kept using 25 in all these problems, but you get the picture. Looking at number 13. We are looking for our GCF, so we have 2x cubed minus 72x. Between 2 and 72, 2 is the biggest number that can go into each. And we have x cubed and x, so they also share an x, making our GCF 2x. So taking out your GCF, or factoring it out, we are left with x squared minus 36. Oh, what do we have here? Difference of two squares. So this needs to be broken down further. And then number 13 would be done. So hopefully this helped a little bit. Again, if you have any questions or any concerns, feel free to email us or post on our Google Classroom page with any specific questions. Good luck, and I'm sure you will do very well. Bye-bye.